Welcome back. Today in the workshop we're going to continue to look at the Incra LS Positioner fence. This is video 3 in a 4-part series. Today we're going to look at the fence on the MFT table. So if that sounds good to you, stick around. The first thing I want to do is to tune the fence to the MFT table. If you watched our setup video here, you'll know that it came out pretty accurate anyway because of the way we use the crown mouldings. So I've deliberately taken the fence completely out of alignment. I've taken the rail on our MFT completely out of alignment, and the back fence is also completely out of alignment. So job 1 is to set the thing up and calibrate it for squareness. The first job is I want to make sure that this fence is parallel to these holes on the MFT table, and for that I'm just going to use some of the Festool small dogs. I'll start by dropping the dogs into the series of holes on the MFT table, and I'm just making sure that the flat faces are facing the fence. I then bring the fence up until it touches one of the dogs, and I'll lock that into position. Now I've deliberately taken the fence out of square, so hopefully you can see I've got a large gap here and I'm very tight against the stop here. So we need to move this fence in this direction to make sure that the fence is parallel to these dogs. If it is, then it's parallel to the series of holes on the MFT table. To do that, I'm going to adjust the Incra base clamp to the crown moulding. Now don't forget that when we set it up it was pretty square, so this is an illustration of how we tune it more than anything. First job, we loosen and remove the 2 back clamps, and I loosen off just one bolt, and the easiest one to loosen off is this one at the end because we can gain access to it. The other one's slightly restricted, so just loosen that off a couple of turns. Don't take it out, just make sure it's loose. Now that's going to allow the fence to pivot on the one remaining bolt that's just out of here, out of camera shot. I then just loosen and remove the crown stop itself. Now that allows me to pivot the fence. Now just by eye, I'm just going to pivot the fence so it lines up to those dogs on the table. I'm going to loosen this clamp one stop, so now I can use the adjuster to actually bring this forward. I'm just going to wind this forward until it starts to hit the dogs. And if I keep winding it, this will put pressure on the dogs and it will also pull itself square to the table. And once they're all nice and tight, this is parallel to the dogs. So I now want to go ahead and clamp this into position. I then put the crown stop back in, bring it hard up to the base and lock that down tightly. Then I can tighten this bolt up again, nice and firm, and just put a couple of turns on this bolt here at the back just in case it's loosened off as we were adjusting. Then drop on our back clamps for a bit of extra security, tighten that down firmly, and the same on this one here. I can now loosen the clamp and take this out of the way. Now I know that this is parallel to these holes, and just to check ourselves, I'm just going to put the stops into a different set of holes. Slide the fence up, and that should now engage and be locked down, and everything should be nice and parallel, and it is. Release the stop, wind that forward so it touches, and yep, that is putting equal tension on all of these dogs. I can tell that because they rotate as they get pushed against the fence. The next job is I want to make sure that this fence here is square to this fence. Make sure you're locked down because when it's unlocked there is movement. So clamp that into position and use a square and just rest it against that fence. An alternative to using the square is you can actually use the MFT. If you've seen the review on this one, you know that it's always clamped itself square. So this is the most accurate square I now have in the shop. And also it's a very long reference fence. So I move that into position and I'm just sighting this gap down here. And just here there is a slight gap. It's not much, it's probably about 0.02 of a millimetre, but there is a gap. So I'm going to loosen off the clamps at the back and just move the fence so it closes that gap up, and now tighten the fence back into its position. So I now have my Incra fence parallel to my table and my MFT fence square to the Incra fence. The next job is I want to make sure that my rail, my Festool rail, is parallel to this fence. Now once again, I've deliberately taken my rail out of square for the video, so you can see I'm on my line there in terms of my trim line, and down here I'm probably a good, nearly 2 millimeters out of square at this end. I slide my rail up until it rests against one part of the fence, and you can now see I'm resting here, but I have a gap here. I'm going to lock myself into position, so this rail is now clamped, and we're going to adjust this rail. Now if you remember from the MFT setup video, it's this small captured nut here, this rectangular captured nut, that determines the position of this bracket when we put it onto the MFT. And it's this bracket that determines, along with its sister bracket on the other side, how parallel that rail is to the table. Now when we set the MFT up, we spent a lot of time getting that square, and now I've taken it out of square for the benefit of this video. So what we're going to do is to square the rail up to the LS fence, and then we'll set the bracket to the fence and then reposition this, and that will make sure everything's nice and parallel. So I drop my rail down, and I'm not using this clamp here, that's down out of the way, it's not used at all. And I'm just resting the fence on the table. I'm now bringing in the Incra LS fence, and I just want to rest it onto the rail, and then I'm going to lock the fence down into the position that allows me to use the incremental adjuster. Now looking where I'm touching, so I'm touching here, but I'm not touching there, and it's this side here, the one that's on the adjustable pivot, I want to reference against. So the fence in this position, I want to move the fence back. Now I'm touching here, but I'm not touching there, so I'm going to wind the LS forward until that's touching all the way across my rail, which is about there, and then I lock that into position. And now I can slide my bracket back along, and I can just engage it into my rail and make sure that everything is nice and tight against my LS fence, and lock that into place. For repeatability, I can now slide along my captured nut, make sure it's held hard against my positioning bracket, and lock that into place. And there you have it. My LS is parallel to my bench. My rail is parallel to my LS. My back fence, my MFT fence, is square to my LS, and therefore, all things being equal, my fence should be square to my rail. And it is, so we are good to go. So that's how we tune the LS to the MFT table. But one of the big things we want to get, don't forget, from the LS is portability. I want to use it in a variety of positions on the MFT, also use it on my CMS. Every time, therefore, I move the system around and I put it back on my MFT table, I want it to be exactly in the same position in terms of parallel and in terms of squareness to where it is now. So we're going to take it off as if we've moved it, put it back on, and then we'll recheck our calibration. And now I've completely taken apart our system. So now we'll put it back together and see if we're parallel and square. The first test, we'll see if this has now become parallel, come back as parallel to the MFT. So put our dogs in, bring the fence up and clamp it down. And that's looking good to me. Now I can bring the rail down, make sure it's seated. Bring the fence up to the rail, clamp that down, and that should look pretty good, and it does. The final thing is to make sure this fence is square. This fence does have a slight play in it on these clamps, so it's the only thing I need to reset. Just bring that into square, clamp it into position. It works. The idea works. We've got portability and accuracy and repeatability in the way we've connected that to the MFT. That is a result. Woohoo! Now the next thing I want to do is to zero the LS system to the table. What I mean is, I want to be able to use this scale here on the LS to dictate the size of the cut. We know we've got a zero clearance cut on the MFT rail because that's how you zero the TS55 to the table and make the cutting channel the zero clearance cutting channel on the table itself. Festool rails, once you've trimmed them down, tend to be 186 millimeters from the back edge to that zero cut that you do. Now just check that to make sure. And we can check this quite simply. We can bring the fence up, we can lock it into position, and using a steel rule I can now just check that measurement underneath. Hold it firm against the table, and that is 186 dead on. And that's also 186 dead on, so no surprises there. Check yours, don't take that 186 measurement as gospel. Mine's 186, that's what I've seen reported for a standard size rail after it's been trimmed. But I have seen some people reporting that theirs was 185. So check yours and see what you get. Mine's 186. Now I know that measurement, I'm going to use the crosshair that's on the LS base to set my steel rule to 186 millimeters. So this is a magnetic ruler, it simply slides along, and I'm going to set that to 186, which is there. And now my rail is zeroed to my cut edge. So the way I can now use this is I can use this gauge and this steel ruler at the back to set the size of the cut. So if I wanted to do a piece of material 300 millimeters long, I can line up 300 in the crosshair on here, lock that into position, use my incremental adjuster to bring it bang on to 300 and lock it down. Now the distance from here to here is 300, and we can check ourselves with our steel ruler. 300 bang on. So that means I can now use the gauge on the LS to set my materials, and that's going to give me an awful lot of accuracy. And don't forget, because I've got the incremental adjuster, then I can really dial that in, and every click that you hear on the incremental adjuster is 0.05 millimeters. So I could use the clamp and the crosshair to rough set 300 millimeters, and if I wanted to, I could then use the incremental adjuster to dial in 0.05 incremental adjustments. So if I ever wanted to do a piece of wood at 300.015 millimeters, I could. So all that's great, and hopefully you can see how accurate that's going to be when we come to cross-cut material, and even rip-cut material, to be honest with you, providing it's not wider than the MFT table and the rail. So let's try it. We'll take this piece of wood. It's a scrap piece of wood. It's not square, so you can see, hopefully you can see the gap there on the material. And we'll take it to 300 millimeters square, and let's see how we get on. We'll bring in the LS just to give it some stability, and also to make sure that this cut is going to be parallel to our LS frame. Lock that into position. I now want to make a second cut, so I can now use the edge we've just cut as our reference up against our fence. Bring in the LS again for a bit of security, but this time I'm not going parallel to the LS. I'm making sure I'm hard and flush against our MFT fence. So using my reference edges against my LS system, my other reference edge against my LS system, and if this has worked, we should now have a piece of material that's 300 wide, Yep. 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 And yep. And it should be beautifully square. Look at that. It doesn't really get much better than that, does it? So there you have it. The LS on the MFT is really cool and it seems to work. But there's more. So the question in my mind is, could I use the LS to set out my panel sizes to give me very accurate rips? Let's find out. So what we've done, we've moved the MFTs away from the wall, so in the centre of the shop, and I've created a super rail by joining my 1400mm rail to the 1080mm rail that's the standard one I use on the table. This end here has got the usual pivot bracket attached to the table but not positioned yet, and on this end here I've mounted the other bracket to secure it into position. The next job is I want to work out the position of this relative to the table. Now I know that I want a series of dogs on this side to allow me to clamp material, because material is likely to overhang the MFT and I want to make sure it's secure during cutting. So I want a row of exposed dogs. So I slide this rail back to about there. Just check I'm somewhere centre on those holes. And that looks good to me. And then I'm going to clamp down this back part of the rail. And then I'm going to bring the LS up so it's resting on the rail, and make sure that the Festool track is parallel and touching the rail once that's clamped into position. And it's not. So we'll once again use our adjuster on the LS to bring that up and clamp it down. So I know that this is now in the right position. It's parallel to my LS fence, it's halfway between the dog holes, I've got clamping ability on this side, and I've got some cutting distance on this side of the rails. With that done, we now position the bracket at this end. Making sure it's still hard against my LS, lock it into position and bolt that down. So I just want to check to see what my cutting distance is now on this rip. So that's going to give me a maximum cutting distance of 419 millimeters. So in this configuration, this is going to allow me to cut boards about 2.2 meters in length up to 440 millimeters in width, and that's not too bad. And if you think about the standard panel size on most cabinet furniture, it's somewhere between 380 and 420, so we are in pretty good position there. Wider cabinets such as kitchen cabinets tend to be approaching 500, and what we can do to get additional width is we can use the extension off the CMS that we looked at in a previous video, and that will move this back and that will give me additional ripping capacity. So that's going to give me quite a lot of capacity, I think. So I'm really quite pleased with that. Now in theory I can use the same technique. I can set a desired width on this one, put my panels in place, and that should cut it to width. I don't have any panels to actually try it with, so I've just made a pretend panel up just using some of my old tongue and groove that I'm using to do the walls on the workshop. And this is currently 230 millimeters wide. So let's cut this panel down to 200 and see if our rip techniques work. Choosing 200 on my fence, on my crosshair measurement, lock that into place, and we'll now give this a go and see what happens. I'm going to set my depth of cut pretty deep because I also need to initiate the table for a zero cut. So now in theory we have a 200 wide panel. So that seems to work. We've now got a rip station set up as well. The maximum cut, 2.2 meters long, is not quite long enough from the panels I use, so the parallel guides do not get made redundant. We're still going to need those as we cut certainly these larger 2.4, 3 meter panels down that I sometimes have in the shop. But the double MFT gives me lots of working surfaces, and the parallel guides will give me that cutting ability that I need. But for stock up to 2.2 meters long, ripping those long panels down, that's really quite useful. So that's a second good use of the Incra fence on the MFT. But I've got one more thing to show you. What happens if I want to cut a piece of material that's narrower than the 186 millimeters that I can get to on my Festool rail? Normally we reach for the parallel clamps, and in particular the parallel clamps extensions. We made a video about that here. Can we set up the LS to manage that situation? Let's have a look. So we're now down at the other end of the MFT table, the end that you don't normally see, and I've just mounted the rail to the MFT. Just want to check that for parallel as well. All I'm doing is just sighting down the edge of these holes, and that's pretty much bang on. So our portability system seems to work. I'm just going to attach the Festool track to the table. So in terms of where I position the track, obviously what we're trying to achieve is a cut that's somewhere between 0 and 186, i.e. the width of the track. In this arrangement, this is the distance we're going to cut, so this will be the piece of material that we keep. So the difference between the Incra fence completely backed out and this edge needs to be greater than 186. I also want to make sure that my material is supported, so I want it in between a row of dogs. So I'm going to find 186 first of all, and 186 is about here. So it's just on the outside of this set of dogs, so we'll set this rail in the middle of those holes. Slide my Incra rail up to round about that middle position. Looks good about there, I should think. Lock that down, and with that locked down I can now slide my rail up to my LS fence and lock it into position. Just use the micro adjuster to move the fence back and forward, allowing me to put the rail parallel to that surface, and that looks good. Lock that down, secure this in with the end bracket. Before we zero the scale, there's one more thing we need to think about. We are cutting on this side of the zero clearance line, so that's not where the cut's going to happen. The cut's going to happen for this piece of material on the other side of the TS55 blade. Using a caliper, I can now measure the thickness of this blade, and that is 2.5 millimeters. So now I know that 2.5 millimeter blade thickness, I can bring up my fence so it's resting against there and lock it down. I then set this scale to an arbitrary hole unit, and that there is 400 millimeters. Now that 400 millimeters isn't important, it's just a reference point for me. So I move this scale so it reads 402, which is there, and lock that down, and then take it into the incremental position. And now I can use the incremental adjuster to bring that to exactly 402.5. So I know that when I use my track saw, it's actually going to cut now to the position of this fence, not the position to the zero cut on the rail. So I now just need to set that to recalibrate this to a usable unit. So we're going to use the top rail, the blue rail, and we're going to set that to 20. And that's just to give me a reference point. So if I want to cut a piece of material 2 millimeters wide, I can now dial that into 2 there on the scale. 1, 2, lock it in, and give me a fine, and give myself a fine adjustment on the increment. So all things being equal, I should now be able to take a piece of material, hold it hard against the fence and clamp that into position. Take the Incra fence out of the way, because we're finished with it now, and that should give me a cut of 2 millimeters, allowing for the width of the blade. And there you have it, a cut of 2 millimeters. Let's check it and see. It'll be interesting. I'm coming out at 1.89, so call it 1.9. An accuracy of plus or minus 0.1 of a millimeter. And look how good that is. You could use that for edge banding if you so wished. And if we wanted to, we could back this off one more turn, because every click on this dial is 0.5 millimeters, and that would give me an accuracy of 0.04 millimeters on that cut, and that is pretty amazing. Just for fun, I want to see how thin a piece I can actually make. 1 millimeter. And you're not going to believe this. Look at that. A 1 millimeter cut of wood. In fact, because of that error that we know we've got on there, that's 0.6 millimeters, nearly 0.5 of a millimeter slither of wood. So there you have it, the Incra LS Positioner on an MFT table. What do you think? Leave some comments and let me know, but personally I'm blown away by that. 0.6 of a millimeter cut, beautifully, repeatably accurate. I could batch those out all day once I've got that fence into the right position. More normal 2 millimeter edge banding, batch that out all day, repeatable. Perfectly square, quickly, 300 millimeters square, all day, accurate, repeatable. Rip cuts, 2.2 meters in length, all supported at working height, no more crawling around on the floors. That will take most standard cabinet panels, excluding the kitchen cabinet. Put the extension on here from the CMS, I can now rip kitchen cabinet widths down all day, accurate, repeatable. Portable, you saw how square it was, how it went back together again. I'm blown away. And bear in mind, I didn't even buy it for that. That was just a wonder if moment. I thought we'd try it out and see, and it's worked out incredibly well. What we actually bought it for was the CMS and dovetails and joinery and box joints and so on and so forth. And if it does the job it's meant to do, as well as it does the job it's not designed for, that is going to be one of the best investments I've ever made inside this workshop. I don't think I need a table saw in this workshop, because that setup on the MFT with that fence is giving me repeatability, accuracy that I need. So I don't think at this moment in time I'm going to need a table saw in this workshop, and that's controversial. We'll look at the router table in part 4. Look out for that. I hope you're finding this really useful. Let me know. If you do, leave me a like, leave me a comment. Don't miss the next episode. That's the one that we're waiting for. See you next time.